Sec 1 Chapter 10.2 Part 1 Sequences. Now in this part of the chapter we're going to learn about what is a general term, and we're going to try to find the formula for the general term of a sequence, and then we're going to do the higher level questions where we solve problems involving sequence. What is a general term? Now in this case, usually we denote it by Tn. Tn is called the general term, okay, where it means for the formula, if you're given a formula, t to the power of n is given to be some formula. Okay, so this means when if it's t1, then n will be equals to 1. If it's t20, then n will be equals to 20. And I'm going to use n equals to 1 or n equals to 20 and sub it inside the formula to find any term in that particular sequence. Now, if we know the formula to find the general term, we can use it to find any term in the sequence. For example, if the formula for Tn is going to be, let's say, 2n minus 1, okay, then we can find any term in the sequence by substituting the corresponding value of n. What does this mean? For example, if I have the formula Tn is 2n minus 1, that means if I want to find term 20, n will now be equals to the number 20. Then means term 20 will follow this formula, 2 times n minus 1, and I'll put n to be now term 20. So this term 20, will follow this rule, this formula, and give us the number to be 40 minus 1, which is 39. That's just one example. Let's try a little bit more questions. Now let's try to find the anthem of a sequence. Okay, given the formula, we're going to sub the corresponding value of n. Now, in this table over here, find the first term and 100th term of each of the following sequences. So, for example, part B, Tn equals to 3n minus 5. That means 3 times n minus 5. That means when I have term 1, now what is the value of n? N will be the number 1. Then I will sub into my formula and I get 3 times 1 minus 5 to give me the answer -2. If I want to find term 100, that will be T100, and n is now 100. Substituting it into this formula here, we have 3 times 100 minus 5. That gives me 300 minus 5, 295. Let's try a little bit more. Part C, Tn equals to n squared minus half of n. So when it's term 1, right, n will now be equals to 1. So I'll get 1 squared minus half or times 1. 1 squared is 1 minus half, and the answer will be half. How about T100? T100 will be substituting 100. So 100 squared minus half times 100. And that gives me the number 9950. Now we'd like to try the following questions over here and then come back with us to check the answers. Have you gotten the answers? Up next, I'll be introducing some of the possible types of sequences. Please write down the following examples into your exercise book. You can pause the video to do the copying of the questions, or you can pay attention first and then do the copying of the questions later. Now, let's consider the following type. Type number 1, where we add or subtract a common difference. Now, what does this mean? Consider the following sequence down here. Let's say we have the number from 3, 10, 17, 24, and 31. What do you think is the pattern? Now from 3, how do we get to the number 10? We can add a 7. And then from 10, we are still going to add 1 7 to get 17. And then another 7 to get 24. And 7 to get 31, so on and so forth. Now, when we want to find a general term in this case, for this sequence, we're always going to start with in relation to the first term. So we're going to find a formula that allows me to substitute some number inside, and I'll always be able to get the answer. So now let's take a look at the following. Now, when n is equals to 1, that means the first term itself, t1, over here, I get the number 3. And then when it's t2, I got the number 7. How did I get 7 from 3? I got 7 from 3 by taking, I got the number 10. How did I get the number 10? I got the number 10 by taking 3 plus 7. Now, how many times have I added the 7? I added the 7 1 time. Right? Now, then what's our next term? Term 3. What is this number? I got 17. How did I get this number 17? From the very first term, from number 3. I took 3. I added 7. 1, 2. I added 7 2 times. If that's the case, can you tell me what is n equals to 4? For the fourth term, term 4, the number is 24. Let's try this pattern. I started with 3 plus 7 times. What is this going to be? Now, this will be number 3. So I'm going to take 3 and I add 7 3 times. Now let's go back to this first sequence. If this pattern is going to hold, then let me check. I will start with 3 and I'll add 7. How many times have I added 7 then? If 3 plus 7, that will be 10, right? But I'm not going to get 10. I got the number 3. So in this case, it means I'm adding 7 0 times. Now observe the following. When it's n equals to 1, term 1, I added 0 times. How to get 0 from 1? When it's term 2, n is 2, I added 7 1 time. How do I get 1 from 2? When it's 3, n equals to 3, term 3, I added 7 2 times. When n equals to 4 and term 4, I added 7 3 times. Can you tell me if n is now equals to 50, my term 50 following this pattern will be what number? That means I will take 3, I'm going to add 7, but how many times of 7 am I going to add? Well, I got 0. I added 0 when it's one term. I added 1 when it's the second term. I added 2 when it's the third term. I added 3 when it's the fourth term. So now what should I add in order to get the 50th term? Well, the answer is 49. How did I get 49? I took 50 minus 1. If I were to have n equals to 100, what will be term 100? Following the pattern, I took 3, I added 7, but how many times of 7 did I add? This is term 100, but I added 99 times. How did I get 99? This came from 100 minus 1. How did I get 49? This came from 50 minus 1. Now, if I were to find the nth term, Tn, how am I going to find the pattern or the formula? I'll follow the pattern and I'll have 3 plus 7. How many times of 7? N minus 1 time. Following this pattern over here. But in algebra, this is not the simplified form. So I have a pair of brackets down here. What do you suggest I can do? Well, we have to expand and simplify the brackets. So we're going to multiply it inside. We'll take 3. 3 is on its own. But 7 is multiplied to n. So I have 7 groups of n and 7 groups of -1, which gives me -7. And in this case, the formula will be 7n minus 4. So therefore, the general term will now be Tn equals to 7n minus 4. Now for this type of sequence where we add or subtract a common difference, the term Tn is usually given by the general term formula will be A, that means this is the first term, plus D, this is given by the difference, times n minus 1. And simplifying that will usually give us the answer to the formula for this type of sequence. Let's try this on another sequence. Given this question over here, I have the following sequence: 201 to become 186. What is the difference? The numbers are all getting smaller and smaller. So actually I am subtracting a difference of 15. 186 subtract a difference of 15, a difference of 15, and a difference of 15 will give me the next few terms. So now let's consider the following. If I were to use this pattern, let's take a look. When n equals to 1, that means I will have term 1. The number was 201. When n equals to 2, that's term 2. I started with 201 and I subtract 15 n minus 1 times, which is from 2, you drop to 1. And that gives me the number 186. Now, if I have n equals to 3, term 3, I will start from 201. I'm going to subtract 15, but how many times? When n is 3, term 3, but I subtracted only 2 times. So to get to the third term, I skip skip, I only do 2 times. So give me the number 171. Now, can you make a guess what will be term 7? If n is equals to 7, following this pattern, I'll get 201 minus 15, but if this is term 7, I'll get 201 minus 15 6 times. And that gives me an answer of 111. Let's take a look. Term 1, 2, 3, 4, 5. What is term 6? And that gives me 126. What is term 7? Hey, I got the number 111. So therefore, this property holds. If I'm going to use my formula over here, what will be Tn, the general term? When it's n, term n will be, taking my very first term, 201, plus a difference, but now I'm not adding a difference, I'm subtracting a difference of, when it's n, I will subtract 15, n minus 1 times. Now this is not the simplified form. I have a pair of brackets over here, so I need to expand and simplify my answer. And I'll get 201 minus, subtract 15 groups of n, negative times negative, subtract negative 15 groups of negative 1, that gives me plus 15. And I'll get the answer to be 216 subtract 15n. In general, this is given by the formula Tn to be taking the first term, a, adding a difference. Now this difference is a negative number, and then the difference is multiplied to n minus 1. Now this is called the formula for the arithmetic progression, where we add a constant common difference. However, this is not the only method to find the answer or general term for this type of sequence. Now let us explore a different method. Let us consider method number 2. Now in the previous part, we have this same sequence over here. We know that we add a common difference of 7. So we keep on adding 7 to each term. By my first method, using the formula, it says Tn is made up of taking the first term, 3, adding a common difference, 7, multiplied to n minus 1. And we get the answer after expansion to be 3 plus 7n minus 7. And that will be 7n minus 4. This was given to be the answer in the first method. Now in my second method over here, we have a little bit of a shortcut. So now I know that we are adding a constant difference of 7, right? So in this case, we will start with 7n. And we need to find out what do we need to do to 7n in order to get to the answer. Now when n equals to 1, 7n will means it will be 7 times n times 1. Now, but our first term is the number 3. Term 1 is number 3. What do I need to do to 7 times 1, which is 7, in order to give me the number 3? Well, 7 minus 4 will give me the number 3, isn't it? So now what we're going to do is we're going to apply this pattern and see whether it fits for the rest of the term. When n equals to 2, if I were to follow this pattern, where I take 7 times the n, which is 2, minus 4, I will get 7 times 2 is 14. 14 minus 4 is 10. Eh? That gives me the number again. So now if I were to have n to be equals to 6, what will be the sixth term? T6 will now be 7 times 6 minus 4. 42 minus 4 will give me the number 38. Let's check. Term 1, 2, 3, 4, 5. How do I get term 6? I'm going to add 7 and it gives me the number 38. So therefore, this formula here, 7n minus 4 is true. And the term and general term will now be 7n minus 4. Let's consider the next example. If I were to use my first method, I will have Tn to be taking the first term, but now I'm subtracting a difference. I'm going to subtract 15. So taking the first term, 201. I'm not going to add a difference. I'm going to subtract a difference. And this is multiplied to n minus 1. So that formula will give me 201 minus 15n plus 15. And I get my answer to be negative 15n plus 216. Now let us see if it's method 2, how can we get the answer? Right? For method 2, I know that I'm adding in a common difference or I'm subtracting a difference of 15. So my formula will start with negative 15n. Now let's check. When n equals to 1, if I have the formula to be term 1, negative 15 times 1, what do I need to do to it in order to get the number 201? Well, I need to add 201 plus 15, 216. Let's check. If n is now equals to 2, if I were to follow this formula, term 2 will be negative 15 times 2. And I'm going to add 216. Let's calculate this. What do I get? Negative 15 times 2 plus 216. It gives me 186. And this is true. So therefore, if I do by this method, Tn will be negative 15n plus 216. So Tn is equals to negative 15n plus 216. And the answers are the same as each other. So now you have method 1 by formula. Formula says Tn is a plus d times n minus 1. Or you can use the second method where you start with 7n and then you find out what is the number I need to add to it in order to get the first term. Which method do you prefer? You may use any one of the methods to find the answer. Some possible types of sequences. Now type 2, perfect squares or perfect cube. Now you can take some time to copy down the questions by pausing the video, or you can write down the questions after you finish watching this part of the video. Now let's consider the following sequence. 1, 4, 9, 16, 25, and 36. What do you notice? If I were to do an addition, plus 3, plus 5, plus 7, plus 25 minus 16, 9, and plus 36 minus 25, 11. We notice that the number keeps increasing, and maybe you'll notice that, oh, it's 3, 5, 7, 9, 11. These are all the different odd numbers or whichever. It can be done in that way, but if I were to ask you what is the more 100 term, how am I going to find the answer? I will need to know the answer, the term before that. So if this is the case, we cannot use this kind of method to help us find the general term. We need to find a formula where, given the formula, I can find any one of the term and I don't need to rely on the term before that. So like for example, if I want to find, this is 1, 2, 3, 4, 5, 6, 7, 8. I want to find term 8. If I were to use this method by adding, I'll need to know what is term 7 in order to get to term 8. But when I do a formula for general term, I cannot rely on the term right in front of that number. So this case, this kind of pattern will not work. Now what do? We'll notice that the numbers are all increasingly in quite big. Okay, so we'll try to see, first thing we can consider is perfect squares, perfect cube, or even power form. So now this is actually 1 square, 2 square, 3 square, 4 square, 5 square, and 6 square. So if I were to give you the nth term, let's say term 100, what will it be? It will be 100 square. So if it's term n, that will be n square. Now this is the first most basic type of equation that you should realize. Okay, so I probably need to encourage you to memorize the series 1, 4, 9, 16, 25, and 36, so on and so forth. Now there can be a couple of spin-offs from perfect squares. So now let's consider the following sequence. 4 plus 7, 4 to get 7, 7 to get 12, 4 plus 3 gives you 7, 7 plus 5 gives you 12, and so on and so forth. You see the numbers again, they are not the same. It's not a common difference down here. So I'm not going to use this pattern, but I observed that the numbers are growing bigger. So let's try. If I were to try a couple of series of perfect squares, 1 square, how do I get 4 from 1 square? Not very sure. Never mind, let's take a look at 7. How about 7? How do I get 7 from 2 square? 2 square is 4. 4 plus what will give you 7? Then how do I get 12 from 3 square? 3 square is 9. 9 plus what will give you 12? Oh, let's observe. I have 1 square plus 3. That'll be 1 plus 3 will give you the number 4. 7 square is 7. I'll get 2 square plus 3, which is 4 plus 3, 7. What do you think will be this term? This is 1, 2, 3, 4, 5. The 6th term. If I go according to this pattern, it will be 6 square plus 3. So therefore, for this kind of pattern, term n will be, if it's a 6th term, I get 6 square plus 3. If it's n term, I'll get n square plus 3. There can be many different types of patterns with squares in it. So I can't give you a conclusive summary list, but here are some of the patterns you should take note of. Next, let's take a look at, for example, for perfect cube. In this case, the question actually gives us a particular pattern. When it's term 1, I'll get 1 cube plus 2. When it's term 2, I get 2 cube plus 2. When it's term 3, I have 3 cube plus 2. Term 4, 4 cube plus 2. What do you think will be the 88th term? That will be 88 cube plus 2. So in general, if I have Tn, the nth term, I'll take n cube plus 2. Have you gotten the answer? Let's look at other types of questions. Example number 2. Consider the following questions. 7, 14, 21. Don't they look very familiar? Well, 7 is 7 times 1. That's term 1. When it's term n equals to 2, term 2, I'll get 7 times 2. N equals to 3, term 3 is 7 times 3. Then 7 times 4 gives you 28. 7 times 5 gives you 35. Therefore, we can generalize that term n, the general term, will be 7 times n, which gives me 7n. Now, part B says, hence, that means I need to use this formula that I've gotten. Okay, Tn is now 7 times n. To find the 99 term, 99 term means it's term 99. So the value for n is now equals to 99. So it'll be 7 times 99, and term 99 will give me 693. Have you gotten the answer? Let's consider example number 3. Aha! Do you find this sequence very familiar? I have 1, 4, 9, 16, and 25. What do they look like? They look like something that we've done earlier on just now, right? So it's 1 square, 2 square, 3 square, 4 square, and 5 square. So this is term 1, term 2, term 3, term 4, term 5. So term n will be n squared, the general term. Hence, that means I need to use this formula. Part B, Tn is equals to n squared. Now find the 27 term, term 27. That means n is now the number 27. And I'll put a 27 square to it. That gives me 729. Have you gotten the answer? Let's look at example number 4. Consider the following sequence. I have 2, 8, 18, 32, 50. Now these numbers look like they increase by quite a number of times. So in this case, maybe let's try to link them to the perfect square that we know. I know that 1 square is 1. How do I get 2 from 1? This is term 1. 2 square is 4. How do I get 8 from 4? This is term 2. Term 3 gives me, this is, if let's say it's related to 3 square, 3 square is the number 9. How do I get 18 from 3 square? Term 4, if I consider it to be 4 square, that will be 16. How do I get 32 from 16? Term 5, 5 square is 25. How do I get 50 from 25? I noticed that 50 and 25, this is times 2. 1 times 2 gives you 2. 4 times 2 gives you 8. 9 times 2 gives you 18. Times 2 gives you 32. Oh, that means if I have term n, I will start with n squared times 2. And to simplify these, term n is n squared times 2, which means it's 2n squared. And now let's try part B. Hence, find its 18th term. Tn is now 2n squared. So T18, n is now 18, will be 2 times. The square is for who? For 2 or for n? So only for n, right? So it will be 18 squared. So it will be 18 squared is the number 324 times 2 will give you 648. Have you gotten the answer? Example number 5. The first term in the sequence is 38. This term is found by, each term is found by subtracting 7 from the previous term. So I show minus 7. Oh, this looks like it's subtracting a common difference. So on minus 7, I get 31. That will be, this is term 1, this will be term 2. They want to write down the second and third term, so I'm going to find the next term. 31 minus 7 will give me the number 24. And that will be term 3. So therefore, part A, term 2 is the number 31. Term 3 is the number 24. Now we're going to find an expression in terms of n for the nth term. That means we're going to find the general term. Now we have gone through this before. For terms with a common difference, in this case, I'm subtracting 7 from my previous term. And this is 38, is my first term A. The difference here is negative 7, A is 38. So we have two different methods. First method, method number 1, we're going to use the formula that we have. Method 1 says term n, for those with a constant difference terms, it will be a plus d times n minus 1. So Tn will now be, taking the first term is 38. The difference is now subtracting 7. So this one should be not adding the difference, but subtracting a difference. And multiplied to n minus 1. Can we leave this as the answer? No, we need to expand out the brackets and simplify in order to get the answer. So we will have 38 minus 7 groups of n, negative 7 times negative 1, that gives me positive 7. And adding up the terms, we'll get the answer to be 45 minus 7n. Method number 2. Method 2 says that if I'm subtracting a difference, so I'll start off with negative 7n. Now when it's the first term, n equals to 1, I get the number negative 7 times 1. What do I do to this number in order to get 38? Therefore, I take 38. Minus 7 plus what will give you 38? Oh, I'm going to add 38 to 7, right? So that will be plus 45. Let's try n equals to 2. See whether this formula works or not. Negative 7 times 2 plus 45. That gives me minus 7 times 2 plus 45 to be, 31. Yes, it's true. So in this case, this formula here, Tn will be negative 7 plus 45. Answer. So have you gotten both the methods? You may choose which method you like to use and then write down the method. Example number 6. The following pattern says it's 1 square minus 0 square. This is term 1, a line, or in fact it's not term 1 in this case. They say it's a line, next line of the pattern. So this is line 1. When it's 1, this is 1 and this is 0. When it's line 2, this is 2 and this is 1. Line 3, this is 3 and here is 2. Line 4, this is 4 and this is 3. What do you think will be the next line of the pattern? That will be, the next line will be line 5. And it will be, if it's 5, then I'll get a 5 square minus, when this is 4, this is 3, so it'll probably be 4 square. And that gives me 5 square minus 4 square. The number is 9. Let's take a look at this part of our pattern. I have 1, 3, 5, 7. How do we get 3 from the number 1? We can do a plus 2. How about 5 from 3? We'll do a plus 2 also. And then this is also a plus 2. Do you see some patterns in this? Now, this is actually another sequence where we add a common difference down here. So we might need to use this pattern later. Okay, now next line, line 9 of the pattern, line number 9. If this is the case, then it will be 9 square minus 8 square. And 9 square minus 8 square will give me the number 17. Now I need to find the nth line of the pattern, line number n. Line n tells me, okay, the first part is still easy. I'll start with n square minus, how do I get this number from here? When it's 5, I got 4. 9, I got 8. If it's n, that means I'll take n minus 1, the whole thing, square. And now I need to equate it to something. What is this part of the formula? I know that there is an addition of a common difference over here. So let's try to work this portion out using a common difference. So our method number 1 says common difference is Tn to be taking the first term plus the common difference times n minus 1. That will be 1 plus, expand out, 2n minus 2. I get 2n minus 1. Or you can use your method number 2. Method 2 says the common difference is 2, right? So I'll start with 2n. When n equals to 1, I will have 2 times 1. What do I need to do to it in order to get number 1? So 2 need to minus 1. So in this case, I got this part of the pattern over here to be 2n minus 1. So this will be the nth line. Using the pattern, find n150 square minus 149 square. What do you mean by they say use the pattern? Oh, this is one, that means I need to use this pattern line number n. Cannot use the calculator to calculate it directly. That means 150 square minus 149 is equals to, that means our n will be what number? 150. So if I use this pattern, I'll get 2 times 150 minus 1. That gives me 300 minus 1. That will be 299. Let's check using our calculator. Is it true? Oh yes, I get the answer 299. And I have used the pattern in part A to help me find the answer. Next, find the integers a and b such that a square minus b square is equals to 101. I need to use this pattern. Taking a look at this pattern, it tells me that this is related to n square. So maybe, and this is related to something square as well. And that pattern tells me I can use this portion over here to n minus 1. Let's say if I were to let 2n minus 1 over here, I'll simplify this part to 2n minus 1 and let it be equals to 1001. Can we find the letter n? Let's try. 2n minus 1 to be equals to 1001. How do we solve this equation? 2n, I'll bring over the 1 over here, negative 1, so it'll be 1001 plus 1. 2n will be equals to 1002, and n will be equals to 501. If I follow this method, if n is equals to 501, square. So this pattern will be 501 square minus, then what will n minus 1 be? N minus 1 will be 501 minus 1 will be 500 square. Let's check. 501 square minus 500 square is equals to 1001. Yes. So therefore, what is A? A square is 501. So therefore, A will be the number 501. B square is 500 square. So B will be the number 500. Have you gotten the answer? Now we'll take a break over here and we'll continue with the next part of these questions in the next lesson. See ya!